In this video, we're going to talk about how to go from mass to mole fractions and then from mole to mass fractions. So why would you want to do something like that? Well, often you're given a stream in a molar flow rate, but you're given compounds and elements in mass fractions or mass percent, and you need to change them in order to figure out exactly how many moles you have of each element or compound. So as I said, we're going to start. We're going to go from mass to mole fractions. And you're usually given this in fractions. Sometimes you're given it in mass percent. It's, as you can see, you do it exactly the same way. So let's say we have a compound that's 36% by mass of carbon, or 0.36, 16% hydrogen, 20% again by mass of oxygen, and 28% or 0.28 mass fraction of nitrogen. So the first thing you do is you assume a basis. Now, since these are mass fractions, you're going to want to assume your basis in mass. You can choose whatever you want, but it often makes sense to choose a number like 100, because what that means now is you have 36 grams of carbon, 16 grams of hydrogen, 20 grams of oxygen, and 28 grams of nitrogen. The next thing you're going to want to do is change your mass to moles. And in order to do that, you use our old friend, the molecular weight, or the molar mass. So if we have 36 grams of carbon, we divide it by its molar or atomic mass, 12 grams per mole, and that gives us 3 moles of carbon in our basis of 100 grams. We do the same for the rest of our elements. And by the way, here I'm doing it with elements, but you can do it with compounds as well. The process is exactly the same. So this is 16 moles. We have 20 grams of oxygen. We divide it by 16 grams per mole, and we get 1.25 moles. And finally, our 28 grams of nitrogen is divided by 14 grams per mole, which gives us 2 moles. So these are the moles that are contained in 100 grams of our compound. Step 3 is to add the moles together. And if we do that, we realize that we have 22.25 moles. And step 4 is to find the mole fractions. And if you remember the definition of mole fraction, it's the mole, for example, moles of carbon divided by total moles. So we're going to do that for each one. We have 3 moles of carbon. If we divide that by 22.25, we have 0.135. We have, and that's carbon. For hydrogen, we have 16 moles. We divide that by 22.25, and we have 0.719 as a mole fraction. Oxygen, 1.25 moles divided by 22.25 equals 0.056 moles. And finally, with nitrogen, we have 2 moles. We divide that by 22.25 moles, and that equals 0.090. So these are our mole fractions. One check that you should always make is to add up all these mole fractions and make sure it comes to 1. Now we know how to go from mass fractions to mole fractions. Well, let's do the same, except go from mole to mass fraction. And We're going to start with the same percentages, except remember these are going to be mole fractions. So we have 36% carbon, 16% hydrogen, 20% oxygen, and 28% nitrogen. So those are going to be our mole fractions. So now, again, we start with assuming a basis. However, because these are mole fractions, and again, let's remember, mole fractions, we should assume a basis in moles. So we're going to assume a basis of 100 moles. The second step is to change moles to mass. Now here with 100 moles as our basis, that means we have 36 moles of carbon, and we multiply it by our molar mass, which is 12 grams per mole, and we get 432 grams. We do that with hydrogen, 16 moles times 1 gram per mole, which gives us 16 grams. Oxygen, 20 moles times 16 grams per mole, which gives us 320 grams. And finally, nitrogen, which is 28 moles, we multiply that by 14 grams per mole, and we get 392 grams. Step 3, add all the mass together. And if you add all the mass that's in this 100 moles of our compound, we have 1,160 grams. And our final step is to find the mass fraction, which, for example, is the mass of carbon or hydrogen or oxygen or nitrogen over the total mass. So let's see what that looks like. We'll start with carbon. There are 432 grams of carbon, and we divide that by 1160 grams, and our mass fraction is 0.372. Hydrogen, we have 16 grams. We divide it by 1160, and our mass fraction is 0.014. Oxygen, 320 grams divided by 1160 is 0.276. And finally, with nitrogen, we have 392 grams divided by 1160, 0.338. These are now our mass fractions, and if we add them together, we end up with 1. And again, similarly, our mass and mole fractions are not necessarily the same, and that has to do with the differing molar masses.